Hey everyone, today I'm diving into a fundamental concept in engineering and physics: natural frequency. Sounds fancy, right? But trust me, it's simpler than it sounds. So what is natural frequency? At its core, natural frequency is all about how a system oscillates when it's left to its own devices. And imagine giving a swing a little push. After that initial nudge, it swings back and forth at a particular rate. That rate is its natural frequency. Natural frequency is an inherent property of the system determined by its mass, stiffness, and geometry. Whether it's a mechanical system like a mass spring setup, an electrical system like an LC circuit, or even an acoustic system, they all have a natural frequency. Let's break it down with some key points. First off, oscillatory systems. Any system that can undergo periodic motion can have a natural frequency. Think of a pendulum, a mass spring system, or an LC circuit in electronics. Next, free vibration. This is where natural frequency truly shines. Free vibration occurs when a system oscillates due to internal forces without any external force acting on it after the initial displacement. Now, how do system properties affect natural frequency? For a mass spring system, the natural frequency is given by where is the stiffness of the spring and is the mass of the object. For a simple pendulum, the natural frequency is where is the acceleration due to gravity and is the length of the pendulum. Then there's resonance. When an external force matches the natural frequency, the system oscillates with larger amplitude. This can lead to significant stresses and potential failure in engineering structures. Yikes. Complex systems can have multiple natural frequencies, each corresponding to different modes of vibration. For instance, a vibrating string has multiple modes, each with its own natural frequency. Let's look at some examples. In a mass spring system, pull a mass attached to a spring, let it go, and it oscillates at its natural frequency, determined by the mass and the spring's stiffness. A pendulum, when displaced and released, swings back and forth at its natural frequency, determined by the length of the pendulum and the gravitational constant. Even buildings and bridges have natural frequencies. Engineers must ensure these structures don't resonate with environmental forces like wind or earthquakes. Mathematically, for a mass spring system, the differential equation is solving this gives the angular natural frequency. The natural frequency in His is understanding and calculating natural frequency is crucial in engineering and design to avoid resonance and ensure the stability and integrity of structures. In summary, natural frequency is the characteristic frequency at which a system oscillates when disturbed and then allowed to move freely. It's determined by the physical properties of the system and plays a critical role in the design and analysis of various engineering systems. Hope you found this explanation enlightening. Hit that like button if you did, and don't forget to subscribe for more insights. Catch you in the next